So I think we are just about there. We'll probably have a few more latecomers join, but let's make a start for everyone. So welcome to our Source Talks on Scala webinar. Just a quick introduction from the team. For those attendees not familiar with Source Group International and our 4 brands, we are international recruitment specialists, and we specialize in tech and life sciences recruitment. At SGI, we're on a mission to achieve the highest level of customer service, driving sustainable improvement and investing in our people. And we launched Source Talks Community as a reaction to the pandemic, with the main goal to build a community around our network and fulfill or insight them with topics that are important to them around tech, talent attraction, and organizational structures and themes. So without further ado, I'm going to hand over to my colleague Francis to do more introductions. Thank you.
Hello. So firstly, big welcome to everyone to the first Source Talk Scala. So my name is Francis, as my colleague Rebecca just said, and this will be the first of many events where we invite leaders from the Scala community to showcase how they're leveraging the ecosystem to, 1, build great digital products, and 2, solve really interesting and fascinating problems. So we're happy to introduce Zuka Kakabadze as our first speaker. He's going to tell us how he's been leveraging the ZIO stack to build his digital signage product, Fugo AI. So just a bit of housekeeping before we kick off. The format of the talk is going to be about 30 to 45 minutes, and then instead of having questions to go through, we'll have a proper Q&A after. So please, if you do have any questions, just pop them in the box, and then I will facilitate that after. So thank you, and over to Zuka. Oh, Zuka, you're on mute.
Thank you, Francis, for the introduction. I guess I can begin my talk. You guys can see my presentation, all right? Yeah.
Perfect.
Cool. Hi, everyone. My name is Zuka. I'm the founder and CTO at Fugo, a digital signage software that allows businesses to create and display content on their screens. Today, I'm going to tell you a bit about our journey and the key architectural decisions you should make for your startup and the reasons why. When you're building a software product from scratch as a startup, the early day architectural decisions you make will have long-lasting consequences. It's similar to building the foundation for a house. The wrong decision can come back and bite, hinder, or even break your startup. I believe most of the problems we encountered are true not only for startups, but for any greenfield software project. So hopefully this talk will be helpful for anyone looking to start that journey. So let's jump in, shall we? The build, measure, learn cycle is well known as one of the key driving forces for any new startup. It's a pretty simple theory. The speed at which you are able to reflect your customers' feedback and the lessons learned on your product determines your startup's long-term success. However, speed and a lean business model alone is not enough to compete against others. You also need focus. Initially, you will need to target a very specific set of customers, and your solutions need to be high quality and enjoyable to use. At Fugo, we were competing against some pretty big companies that had massive feature sets, targeting everything and anyone in the market. However, large and bloated systems are complex, hard to build, and even harder to use. The lesson here is that if you try to squeeze too many features into your new software from the get-go, you will not only most likely fail, but you will also be on your way to becoming exactly like your competition, which is what you set out to avoid and improve in the first place. Instead, concentrate on quality as opposed to feature quantity. Build a limited number of key features you know your customers need and want, that are reliable and really enjoyable to use. And fewer bugs as possible are important too. So how do you build a lean and agile software that allows your startup to grow fast and release high quality features? Well, in simple terms, by managing complexity. It's very easy to build an overly complex system that's hard to understand and iterate. Software complexity reduces speed, decision-making, and can ultimately kill a startup. You instead want to aim to have modules that allows you to easily reuse, build, and rebuild new solutions, a bit like Lego blocks. Modularity not only decreases complexity, but this allows room for an increase in creativity, which is very important for a startup. You don't need to invent anything new or use the shiniest tools to tackle complexity either. We already have battle-tested tools that help us to manage the axis of complexity. We have three main types of complexity to consider when building a startup when building a software in a startup. Domain complexity. This is solved by domain-driven design, which allows you to create models that map to the real world whilst allowing for continuous change. Solution complexity. This is solved by functional programming, which helps you to build modular and composable code. And lastly, system complexity. No matter how well you design your model or how functional your solution is, if the responsiveness of your overall system is bad, your application will be a failure. That's why reactive system principles are so important to manage the complexity of multi-core or distributed applications. You do not want your users to be blocked before your application returns a result. And reactive manifesto principles ensures that your system is non-blocking, responsive, and doesn't suffer from an unbounded latency. Next, I will show you how to apply DDD, FP, and reactive system principles to your software. You want your logical architecture to be indifferent to the physical architecture. That's because the two evolve independently as your business grows, and you need to tackle them separately. Ultimately, the goal is to build a logical architecture that can be run on any physical architecture, whether it's a monolith, microservice, or even serverless, with just the push of a button. This allows you to be ready for change from the get-go and respond quickly to new circumstances that are inevitably thrown your way. At this stage, you should ideally know the problem you're solving and ought to have a number of solutions that you want to build and test with your users. At Fugo, we initially prepared UX designs describing Fugo's domain and core functionalities. The designs clearly outlined must-haves, good-to-haves, and future features on a very granular level. Granularity is important because it allows you to break down complexity and minimize the risk posed by change. For example, if we want to change the way uploading images work, it should not affect the way screens are paired. Crucially, every core feature from the UX design was mapped to a workflow to kickstart the architectural design. So what is a workflow? A workflow is one of the basic units of high-level FP architecture, and it represents a feature, a scenario, or a story. Workflows are built using pure functions as independent units, containing only the functionality they need. Like functions in low-level FP, a workflow is standalone at the architectural level and is a basic building block, composable like low-level functions, and have no side effects. And from an architectural perspective, a workflow is one directional pipeline with inputs and outputs. The workflows we implemented in Fugo generally have a similar structure. A command is sent as an input, a business decision is made, data is transformed, and then finally new data and events are produced as output. Our next task is to group these workflows into logical units called bounded contexts. And for that, we use DDD. When grouping, you need to have a low coupling and high cohesion. Low coupling means that the connections between services are minimal and that they don't share information unless necessary. This helps you to pull apart and rewire your application into new configurations, making your application more flexible and responsive to the changing needs of the business. Whereas high cohesion, on the other hand, enforces that the code that changes together lives together. And bounded context does not solve more than one problem. And in order to avoid too many chefs in the kitchen problem, a bounded context should be owned by a single team or a developer. So how does this relate to the physical architecture? If the entire system is implemented as a single monolith, a bounded context could be a simple module within a single container. Alternatively, each bounded context could be deployed separately in its own container, like in a classical microservice architecture. Or we can go even more fine-grained and make each individual workflow into standalone deployable container, like we see in serverless architecture. However, at this early stage, we do not need to commit to a particular approach. The translation from logical design to the deployable equivalent is not critical, as long as we ensure that the bounded context stays decoupled and autonomous. So how did we do things here at Fugo? I'm going to show you a simplified version of how we initially divided Fugo into bounded contexts using DDD principles. As you can see, the billing bounded context is independent from the screen bounded context. Some features might require multiple workflows from different bounded contexts. And in this case, communication is achieved using events. Workflows within a bounded context are triggered by these events. And event triggering a workflow is a logical view, not a physical one. So for example, this can be implemented either as a request response, which increases coupling, or as event-driven, which decreases coupling, or a bit of both. So we call this hybrid. If bounded contexts are not correctly created, you'll eventually turn your nicely decoupled architecture into a big ball of mud. How can we structure our code within a bounded context? The natural intuition is to use a traditional layered approach where workflows basically go through every layer. But this approach is problematic because any change in the workflow propagates to other layers in the workflows. This architecture also significantly reduces our ability to extend and iterate, so it is not ideal. Instead, you invert dependencies and make them point inwards, following functional onion architecture. This way, the infrastructure code knows the core domain, but not the other way around, and I/O is kept at the edges. The domain entails just pure logic and is isolated from the infrastructure. For example, a function that interacts with the database is impure and therefore will not exist in the domain. The core domain consists of algebraic data types, also known as ADT, and pure functions that operate on ADTs. This is called algebra. And algebras allow you to mathematically reason your code and allows you to create high quality testable software. By encoding business rules using types, you literally cannot create incorrect code. You can then use the static type checking almost as an instant unit test, making sure that your code is correct at compile time. One advantage is that this isolation of business domain from infrastructure occurs naturally. You don't need to encourage developers to use this onion architecture. It happens automatically as a side effect of the FP. This approach can increase your time to market, but it improves the reliability of your code and means that any future changes can be rolled out with fewer tests and with greater confidence and speed. So let's look at an example of what a Fugo workflow looks like. We want our code to represent a pipeline. For example, when you publish a Fugo playlist, the flow goes as follows. You get a playlist from a repository, send an event that says playlist is published, log that playlist is published, and return playlist. So this is just an example. In our code, we have a function for each step. Each step needs to be stateless and without side effect, so it can be tested and reasoned independently. In practice, however, chaining pure functions into workflows is harder than it sounds, because the output of the function does not match the input of the next function in the pipeline. There are two reasons for this. Functions have dependencies and extra parameters that are not part of the workflow pipeline. And they also have effects, such as errors. And up until recently, actually building such an architecture was unimaginable, even for a startup, and required a considerable amount of acrobatics and resources to achieve this. In order to build a functional architecture, you need a functional programming language. That's why we decided to go for Scala ecosystem and ZIO. We were attracted to using Scala because it has a powerful and expressive language with a strong type system and type inference. It allows us to reuse existing JVM infrastructure, which is important for startups as the time to market is very short, and you can reuse a lot of libraries and functionality. And it has first-class modules. Traits and objects in Scala help define modules that can be composed and help evolve larger components out of small ones. So there are various ways to implement functional and reactive software in Scala, like futures, cats effects, akka, to name the few, but they don't tick all the boxes. So we decided to go with ZIO, and this is why. ZIO is a library that combines FP, object-oriented programming, reactive programming principles, and allows us to build modern applications on JVM that is modular and easy to update. ZIO applications are easy to understand and test, and are resilient. The reason why they're easy to understand and test is because it helps us to easily build complex applications through a combination of descriptions of interactions with the outside world, also known as functional effects. And the reason why they're resilient is because it takes a full advantage of the Scala type system in a such way that it can catch more bugs at compile time rather than at runtime. So just by looking at the signature of the ZIO function, you can tell if the function has dependencies, and the typed errors can tell if it can fail, and if so, how. ZIO tells you where and how your application can fail as well, and this leads to bulletproof applications. And finally, using fiber-based models, ZIO allows you to make your application more reactive. ZIO is the most important data type and represents a functional effect, which means that it contains a description of a series of interactions with the outside world, like database call or API call. This means it needs context R to run. The context can be a dependency like a REST client or a configuration. It may fail with an error for a type E, or it may complete successfully with a return value A. I think in this case R, but I will show you how ZIO helps you build compositional code in real life and how you can iteratively change and add features as you would in a startup environment. So let's take one of the functions from Fugo, publishing function. We allow our users to choose videos from Unsplash stock library and display them on screens. So this is a simple function where basically we need to get the URL of the video, format the video, and then send it to screens. So this is what a simple ZIO function would look like. However, let's say you observe that reading from URLs sometimes can fail due to some networking issues, and you want to retry up to 10 times before failing. With ZIO, you can simply add a retry policy like this, and you can easily achieve this functionality. So then your requirement changes again, and you want to allow your users to display multiple videos straight away on their screens. So instead of one URL, now they can send multiple URLs. So they can choose multiple videos from the Unsplash stock library. Using ZIO compositionality, you can actually use a for each method that goes through every URL and applies the format video function. And this is really easy to do. So now let's say you want to fail if the formatting takes more than 5 minutes. So you add a timeout fail function to your pipeline. Then you realize that formatting many videos at the same time in a sequence takes too long, and you want to reuse the parallelism of your server. So by using for each par, we'll actually apply format video to every URL in parallel. However, you realize that Unsplash has a limit on number of connections you can make, and that's 10. So you can actually put that limit, pass that limit as an argument. So now you'll download the videos and format them in parallel, but in batches of 10. So as you can see, ZIO allows you to easily reuse and compose existing functions into much larger and complex objects that is easy to reason and understand. And this is especially important for startups because your requirements change all the time. Now I will show you how to use ZIO to build a workflow pipeline. As you remember, this was our logical workflow pipeline for publishing playlists. This is what our publish playlist workflow looks like in ZIO. ZIO instance describe effects that take an input and produce either an error or a desired value. And ZIO has 3 argument types, which is input type R, which is environment or dependency, the output type, which is E, the error, and the value type. And you can see how they are reflected in the type of the function. The publish playlist functionality sequentially composes all the sub-functions using for comprehension. The sub-functions themselves are ZIO types as well. If successful, publish playlist function returns a playlist. If there is a failure at any stage in the pipeline, it produces playlist error type describing the error. This function does not actually run. It is just a description of a workflow. To run it, you need to provide the dependencies. You can create dependencies in ZIO using zlayer. By the way, I forgot to mention that we used ZIO1. So some of the syntax is actually changed in ZIO2, which is much improved. So I'm going to stick with ZIO1 for initially, but the kind of concepts are the same. So you can create dependencies in ZIO1 using Z layers. Z layer allows you to create services that can then be composed to build a graph of dependencies. The example above shows playlist queue service API that lives in our domain layer, where our logic lives. And below that is an SQS implementation of the playlist queue service. This lives in the infrastructure layer. The graphs can then be injected into modules to make ZIO workflow runnable. For each bounded context, we then construct dependency graph and inject them into our Scala module. These modules are either run as a separate microservice or as a modular monolith. In a modular monolith, that Z layers allows you to share dependencies across modules to save resources. For example, HTTP client pool. And this is a really cool feature. In order to run our published playlist workflow, you need to provide the layer graph as shown here. So now I'm going to talk a bit about a physical architecture. After completing our logical architecture, we need to consider technical requirements and map logical architecture to a physical one. Each Fugo bounded context or module has a different requirement in terms of scaling, availability, and behavior. Currently, we have 8 microservices running on AWS infrastructure and 1 modular monolith called Fugo CMS. Fugo CMS is deployed as a modular monolith because initially it was clear which workflow would require scaling and which would not. Each module in the monolith has its own DynamoDB table and SQS queue that can scale with the module. We put them in a monolith because microservices can have an operational overhead, but you can mitigate this by automating infrastructure and using cloud services to their fullest extent. This allows you to focus on business code and less on the administration code. On the other hand, we knew that the router module that coordinates screens needs to be a singleton and be deployed as a separate microservice. Separation between Fugo CMS and the router was obvious, as scaling requirements are completely different, and we do not want the router to affect the user experience and Fugo CMS to affect the screen functionality. So what is the takeaway from all this? As a startup, you need to be lean and agile. By building modular software, you can iterate your code quickly to reflect your business requirements. Scala and ZIO will enable you to easily apply domain-driven design, functional programming, and reactive programming principles to build a truly modular and composable solution. This gives you the ability to break down the problem to smaller problems and then solve them individually. The beauty comes when you start composing those solutions into a new solution. The composition and abstraction gives you the ability to reuse code across your code base and team members. It's not only that you are building quicker, you're able to build high quality software as well. Thanks for listening and happy to answer any questions.
Thanks, Zuka. That was great. Please, anyone who has any questions, feel free to put them in the Q&A and we can facilitate. Zuka, Michael Lacko asked, So ZIO bracket
Yes.
I was wrong, right?
Yes, that was wrong. That was my mistake. Yes, so you'd have instead of R, you would have a different type parameter, which indicates the success type of the success value.
Any more for any more? Any problems with ZIO2 so far?
So we haven't actually tried it in production, but we are planning to migrate our ZIO1 to ZIO2. As far as I know, there are no problems with ZIO2. We actually started using ZIO even before it was ZIO1. So it was kind of a very risky decision, but the fundamentals were so strong that we were quite happy even before the performance of the ZIO, even before ZIO1. So I'm sure ZIO2 would be even more reliable. I guess the only problem might be the library compatibility. So some of the libraries that we are using still depend on ZIO1, but in general, no.
Couple more questions. What did you use before ZIO and why did you move to it? And then how difficult has it been to find developers or train Scala ones on the ZIO ecosystem? How long for people to be fully productive?
Yeah, sure. So I'll answer the first question. So we actually, this was a greenfield project. So we started from scratch, but we had an MVP, which was actually written in Akka. We use Akka actors and Akka streams. We didn't have any distributed computing kind of requirements, but for some reason we kind of chose that framework because we thought that the scalability would be kind of one of the main issues that we would face. But we were wrong. That was not the kind of the issue that we faced. But essentially, it all came down to how easy it is to use, how the community, and also how well the functional programming principles are reflected in the library. So that's why kind of we decided to use ZIO for our main product and leave Akka with the MVP out of it. So the second question is, how difficult
has it been to find developers or train Scala ones into ZIO, and how long before they've been fully productive?
Yeah, sure. Actually, I want to add one more thing to my other the previous question is that we used Akka and we also use a lot of type level CATS effect features as well. So and I think this is relevant for the last question, is that I think for ZIO it's quite easy because we have like Java developers who became proficient in ZIO very quickly, even without having any experience in functional programming. So that is really cool. Like for other kind of solutions, you kind of need to know a bit about what you're doing, like theory, whereas in ZIO you don't need to. So adopting ZIO in a team that doesn't really know functional programming is really easy. And even you don't even need Scala as well. Like Java programmers can pick it up quite easily. So that's our experience.
Perfect. Just out of interest, Zuka, like a question from myself. You said that there was very low risk in just moving forward with ZIO. What were the risks, and what were the pros and cons? I mean, other than what you discussed in the actual presentation.
So I guess in terms of cons, so it's a different way of thinking about building an application. And there is a learning curve. I will not say that you can immediately start building things, but there is a learning curve. One thing that I kind of haven't mentioned is that like ZIO really kind of allows you to concentrate on worrying about the business logic, and a lot of the kind of functional programming discipline that usually teams have kind of is not required anymore. Kind of ZIO forces you to be functional, and that's really cool. So that scales really well across different teams, across different repos. So the code becomes uniform, and that is a very good kind of way of collaborating with different members in your team, and even like outside of your team.
Okay, perfect. And another question: why ZIO and not Cat's effect? Why does ZIO make the difference?
So our decision mainly came down to the aesthetics of the API and having so it was, we didn't have a big kind of reason initially why we went with ZIO. The community was also very kind of responsive and helpful with ZIO. So if we had issues, they would immediately help us. We actually worked with Scala, which is a software agency that had really amazing professionals to help us get started with things. But in general, a combination of kind of aesthetics and the community was kind of the main reason, because when you're a startup, you don't really have kind of resources to analyze various libraries in deep, and yeah.
Okay, perfect. Any more questions, or shall we wrap up? Oh no. Do you find ZIO fun to code in compared to other languages?
Yes, definitely. It's very pleasant to use. So you kind of worry about how to build things. You worry about like what you're actually building instead of how you're doing it, which is quite cool. So this that's I'm kind of referring to this aesthetics of the API. So it's really a tool for building kind of business solutions. So.
I think that is it. Any more comments, Zuka, or are you good?
I think there is one more question.
Oh no, yeah, we've just had another. What kind of guarantees ZIO? What kind of guarantees ZIO provides coming to licensing? Do you have any idea?
I have no ideas. It is an open source project. I think you're asking this because of the situation with the ACA and the Lightband. But I think that's slightly different because they were funded by venture capitals, and they're